Hello, everybody, and welcome to this session. And thank you for joining and taking time today. We'll be discussing SQL modernization and addressing some of our common complex patterns and blockers and IPs that we've managed to harvest from our customer engagements. My name is Des FitzGerald. I'm a principal engineering architect in the database platform engineering team at Microsoft. And I'm joined today by my colleagues Naveen and Sumit. And together, we're very, very excited to be here today and to be able to talk to you about some of the main enterprise requirements and discussion points and blockers that we see daily in our engagements with customers. We want to talk as well about how we address these points and overcome these, and where we've indeed developed some custom IP to help you as well as you progress through your SQL modernization journeys. So, without further ado, let's get started. The agenda today will take us over the modernization and migration patterns that we encounter, the main areas of complexity within such projects, and the blockers that we encounter from a technical perspective. Then we'll address the approach that we recommend to understanding our migration tooling options. We're well aware there's a lot of tooling out there, and we want to give you some insights into the various tools we have. We're then going to step into customer examples and success stories, as well as our harvested IPs and assets that I mentioned earlier. Then we're going to have a demo session from Sumit, where he will address large database migrations using a custom IP based on Spark that we've created. And finally, we're going to go over the key takeaways that we want you to take with you today and give you a list of resources and assets that may be able to help you in your modernization journeys. And finally, we're going to have a session at the end for questions and answers. So, on to the first area. One of the main areas and places that we see customers encountering functional patterns and complexities and broader potential blockers is around the following topics. Handling special schema objects within databases is always an area where we see our customers coming to us and having particular concerns. We have a great tool that can help you identify some of these objects that may be problematic during your migrations, but in many cases, our customers are coming with user-defined functions, user-defined types, in-memory objects, or features such as file stream, file table, resource governor that they've been using over the years and are now having and facing issues in their migration journeys. We have a number of helpful IPs as well as first-party tools which can identify these for you with remediation steps as well to help you along your way on your journey. And we'll be talking about those later when we get to the tooling section. SKU recommendation and optimal sizing for the potential target is another area where we see customers facing challenges. Everybody has their idea about where they want to migrate their SQL workloads to. What we've discovered is that one of the main areas that customers face some challenges on is when they're trying to understand whether it would be a better fit for their workloads to go to Azure SQL Database, Azure SQL Managed Instance, or indeed to SQL on Azure VM. What we've done is built a very powerful SKU recommendation engine into our tooling, which we'll be also discussing later, which can give you some good insights into not only an optimal service that you can use, but also the optimal sizing for that service for your workload. Data ingress performance is another area where it needs careful consideration, especially for larger data sets, moving that data sometimes across quite complex network topologies can be a challenge. In those areas, we also have best practices and guidance on what you should do and how to approach that. Faster data transfer for blob and large data types is an area where a considerable amount of customers are having challenges. This can also be an area where some redevelopment of the existing structures may be required. However, we do also have built up some very good IP that can help for these scenarios where you're trying to move such data types. We do understand that there are challenges around that, and we have given some guidance on that, and in the resources section and in our documentation, you'll be able to read more about that. Data validation post-migration is an area where we also are very aware that customers want to know not only that they were able to, as the previous points were saying, move their data at speed and move complex data also at speed into their new Azure data service, or in this case, Azure SQL, but they also want to be able to validate that that data has arrived. We offer up a customized solution for not just doing a simple row count based analysis on the validation of your data movement, but also based on MD5 hashing, a more complex data validation or data compare tool, which we also have linked in this talk, and which is a very useful tool for overcoming some of the concerns that can come along with moving vast quantities of data from your on-premises SQL environment to Azure SQL. VLDBs are becoming more common across all industries. Data is the new gold. Nobody is willing to remove their most valuable assets within their enterprises or organizations. And what we're seeing are huge volumes of data being built up in within databases. So the prevalence of VLDBs within environments, as we're discussing some of the complexities around data migration and database migration to Azure SQL, is one area where we're constantly improving what we offer and building up IPs to help you move your VLDBs to Azure. We do understand that there are concerns. We do also understand that there are limitations, especially around transfer of large data. It goes back to the data ingress performance point from earlier, but you're going to see later in the demo from Sumit, one of the clever IPs that we've built up to help you address VLDB migration and address the ability to be able to move large data sets into Azure efficiently. Application concerns, of course, is another area that we do see common pattern and complexities around. No database exists in isolation. There's always an application accessing that database. Those application owners have their concerns around various topics once their databases move to utilizing Azure SQL from previously accessing their databases on premises. We offer a number of tools. We'll list some of those tools later, where some of those access patterns can be identified and can be helped mitigate some of the issues that can occur, especially around connection strings embedded in application code, where we can help your developers or your operations teams, your DBAs, identify the areas where there may be some concerns around both the code and the suitability of that code accessing Azure SQL, as well as the data access patterns. Retry logic is another area where we see a lot of, I would say, post-migration or pre-migration also, areas that customers are maybe not aware of. As you transition from an on-premises environment utilizing SQL Server to Azure SQL, we would highly advise, and we have a lot of documentation and detailed documentation on how to implement correct retry logic within your application layer, as well as other layers, in order for you to be able to ensure that your application functions as expected post-migration of your database to Azure. This is an area that we also see a lot of customers who are undergoing modernization projects come to us and really want to address how they can benefit from the high availability or built-in HA kind of DR possibilities of our platform services. But they can only do that if they make good use of retry logic at the app layer. So we have good documentation around that. One of the other areas as well is downtime during a cutover. So after migrating your database and after migrating across to Azure, how do you optimally minimize the amount of downtime that you incur in order for your really tier 1 applications to successfully migrate to Azure? This is an area of it's a pattern that we often see. It's an area of complexity and worry for some customers. We offer very good and well thought out solutions about how to minimize that downtime during cutover, whether that's by utilizing some of the features that are built into some of our Azure SQL PaaS services, such as LRS or MI Link, which we'll talk about also as tooling later. We give very good indications to our customers about what the best solution for them to minimize this downtime during cutover is. Efficient disaster recovery, I've already addressed. Coexistence requirements is an area as well, which is extremely important for many customers. They want to initially run in both locations for a period of time. So have a so-called coexistence across their on-premises and Azure. And there too, we have built into our services as well as into our documentation some possibilities for those coexistence requirements to be met by way of these features. Performance optimization post-migration is an area as well that is an area of concern as well for customers. What we also can do and have done there is gotten and gathered a lot of information from our customers about some of the major challenges that they've faced in terms of performance post-migration, some of the changes that may cause initially some performance related issues, but nothing can beat good testing, and pre-migration testing of your workload is always advised. But the performance optimization potential within Azure SQL is also very high. And there we have very good documentation, especially for customers coming from legacy SQL Server like 2008. Some of the features within Azure SQL can really help in those areas, whether that's query store or the like. Finally, what we see as a common pattern is also the requirement for regulatory reasons or other reasons to have the possibility to get your data back on premises. And here as well, we've built up some custom IP while we work on more long-term solutions to these problems. We've built up some very valuable IP which can help you really bring your data for regulatory requirements or the like, give you the option for migrating your data back from Azure SQL to on-premises or even between services within Azure SQL itself. So next slide, please. Okay, on the SQL Server migration tools, there's an extensive list of the migration tools here. I'm not going to go down through each one of these individually, but what I would say is that in many cases, we hear from our customers that we offer a lot of options in terms of migration tools, and it's often confusing in certain cases to our customers where we would advise which tool to use. Earlier I would like to call out one area I was mentioning earlier around a tool for assessing your data access. And that tool is called the Data Access Migration Toolkit. It's not listed here currently, but I will include that in the slide deck. So Azure Migrate is our enterprise hub for starting, executing, and tracking the entire Azure migrations. It would be our preferred solution for you if you're moving a large quantity of instances or databases to Azure. It can give you a single pane of glass view over the migration of those environments to Azure, and it's a very powerful tool for orchestrating and coordinating those migrations. Like I mentioned, I'm not going to walk down through each one of these, but I do want to also call out on the managed instance front. I mentioned managed instance link and log replay service. Both of these are very valuable tools if your targeted environment is Azure SQL managed instance. Both of those have specific use cases. In the case of managed instance link, it can be a very valuable tool if you want to have access to the to leave your database in your on-premises environment, but replicate through the use of distributed availability groups your database into managed instance and use your managed instance database as a read-only copy of your production instance, which remains on premises for read workloads. So if you wanted to do read scale out of specific workloads to Azure, utilizing managed instance as your target, managed instance link can be very valuable for that, as well as a migration tool in and upon itself. And the log replay service as well is a very valuable tool and a component used by multiple other tools in order to facilitate the migrations to managed instance. We can go to the next slide. So in general, as I mentioned, and in the previous slide you've seen, there are a number of tools which can be used to facilitate migrations and modernization of your existing SQL Server environments or databases instances to Azure. We give you this choice. This is important to point out before talking to this slide. We give you this choice, these choices of tools, not because we want to confuse you. The reason that we're giving you this choice is that we really want to give you the best tool that suits for what you're trying to achieve. We have built in within Azure Data Studio a new Azure SQL migration extension, which is a really powerful tool for you to be able, from an end-to-end perspective, to do analysis or assess your current databases, to do recommendation of target and sizing of target, as I was mentioning earlier, and as well directly within that extension, the possibility is also there to do the migration. This is a very powerful tool and one of the tools that we would highly recommend you go and look into if you're going to be looking at assessing handfuls of instances or individual databases or individual instances for migration. If you're going to be looking at a much larger scale for assessing and discovering your SQL Server environments and getting an idea around assessing their readiness for migration, as well as sizing for potential targets. We also, as it says here on the top row, if you're today running on VMware, we offer directly within Azure Migrate an experience for you to be able to do that within the Azure Migrate tool or service itself. And then as you progress towards the migration, you can then also use the SQL migration extension within Azure Data Studio. For non-VMware environments, and by the way, just we are of course working on that. It's not that we're only ever going to within Azure Migrate be supporting VMware, of course not. We're working currently on supporting also SQL estates on Hyper-V, on bare metal, in other clouds and the like. It's just today it's limited in scope to VMware. If you are in the situation where you need to assess at scale your environments, which are needed to be migrated to Azure, then what you can also do is the tool that I was mentioning, that the extension that I was mentioning that's built into Azure Data Studio, called again the Azure SQL Migration extension, that can be also scripted through PowerShell and CLI or CLI to assess at scale for readiness to migrate, and also identify through SKU recommendation optimal targets and sizing of those targets. And it's very well documented, and we have also some metric information to share on data size migration and timings and the like within our custom IPs. And with that, I would like to hand over to Naveen, who's going to take you into the customer success stories and harvested assets. Naveen.
Thank you, Des. As Des went over the different migration scenarios and required tools in the previous slide, now we would like to present one of the largest SQL DB customer, Udan's migration success story. Before we talk about the customer requirement, just few words about Udan. Udan is India's largest online B2B marketplace. Udan has linked more than 3 million sellers in 900 cities with 25,000 suppliers. They were running their high-volume transaction-intensive B2B platform on Azure SQL Database Service. Let me go over one of their complex database migration requirements. One of their mission-critical database that required high throughput and low latency was running on an M-series SKU for a while on SQL DB. SQL DB M-series supports only up to 8 terabyte storage. This database has grown to 7 terabyte in size. To address the storage limitation and their business requirements, they started archiving the data on a periodic basis. Out of the 7 terabyte size, the total used space is only 3.5 terabytes. Customer wanted to shrink this database to recover the free space. They have tried various shrink database techniques and tested, and they did not yield any success. Here are other details about this environment, along with the storage details mentioned above. The workload is not CPU bound, and the CPU utilization is around 15 to 20% on a typical day. Customer is very concerned about the high operational costs on Azure SQL DB M-series. Udan has the following requirements for the target solution. So we work with Udan, and Udan is very much satisfied with the SQL DB service, and they are looking for some cost-optimized Azure SQL DB SKU that is comparable to their existing M-series SKU with no performance impact. They have another requirement to move while moving to a different target. The main requirement is the minimal downtime. The max allowed cutover for this particular workload was 1 hour. Udan worked with Microsoft engineers and decided to test this workload against SQL DB business critical SKU. To do that, they need to move their 3.5 terabyte VLDB from M-series to business critical. Here are some of the techniques tried by Udan team to meet the business requirements. As there is no Microsoft first-party solution to logically move data from Azure SQL DB M-series SKU to a business-critical SKU, Udan tried various techniques, for example, data migration using Delicium and other third-party tools. None of these techniques did meet the above downtime requirements. So our team was engaged with Udan to provide a solution that can meet these workload requirements. We did the migration in two phases. For this logical data movement of 3.5 terabytes to Azure SQL BC's queue under 1 hour. So what we did is we split it into two phases. The first phase is the fully loading the data using Databricks. And the reason why we chose Databricks is we want to leverage parallel reads and writes of tables to lower the data load times. With this solution, we were able to leverage parallel reads and writes of records within the table as well. We also pointed the Databricks to the secondary replica to read the data from the secondary replica to minimize the performance impact on the production system. In phase 2, we enabled the CDC on the source as well. We executed CDC procedures on the source to capture incremental changes to CDC tables for each base table. We copied CDC records from source to the target, and then we executed CDC merge procedure to merge incremental changes with base table on the target. We also scheduled 3 jobs to basically synchronize this data onto the target. Before we go on to the demo, we would like to highlight few IPs we harvested from the data migrations, working with several different customers. As Des already mentioned, we wanted to highlight some of these common patterns and the IP we have harvested from those patterns. The first one is data migration, reverse migration between Azure SQL DB, MI, and SQL Server. In this post, we wanted to address a common ask working with multiple customers. This is around the need of migrating databases between the various Azure SQL offerings, as well as reverse migrate the databases back to on-premises SQL Server running in their customer environments. And the next one we want to highlight is the data comparison toolkit. Data comparison toolkit is when a customer moves data from one database to another, whether it is from one database vendor to another or just one server to another. In many cases, you want to make sure that all the data was transferred and nothing was lost in the process. This data comparison tool helps in comparing the source and target data with the appropriate drivers. The tool supports both SQL Server, Oracle, DB2, Teradata, Netezza, PostgreSQL, and MySQL as sources, and SQL Server as a target. And the next IP is data migrations to Azure SQL Managed Instance using full and differential backup. We have talked about the other tools for online migration, such as LRS and SQL MI Link. This blog is specifically focused to guide customers to help accelerate migrations from on-premises or RDS or other relevant SQL Server implementations that needs to be migrated to an Azure managed instance with little downtime and just having only full and differential backups as the only option from source. Basically, some customers do not have access to log backups. So this IP is going to help customers to migrate these databases to managed instance. And the next one is the SQL Server replication as a tool to migrate very large databases to Azure SQL DB hyperscale database. This post will discuss how to utilize SQL Server transactional replication to migrate an extensive 5 to terabyte database to the cloud over a standard internet link from an on-premises source location to the Azure cloud. And this is definitely used for very large databases where the bandwidth is the bottleneck. And we have worked with several customers and migrated their customers using this tool as well. And the next one is heterogeneous linked servers from Azure SQL Managed Instance. Often when migrating from on-premises SQL servers, the topic of linked server implementation is a frequent ask. As there are different levels of support in Azure, there is no out-of-the-box solution. As the linked servers to heterogeneous data sources like Oracle is not supported by Azure SQL Managed Instance, this block talks about the solution to implement the linked servers connectivity between SQL managed instance and heterogeneous data sources. In addition to all these IPs, we also want to highlight a couple more converting agent jobs into Elastic jobs when customers are migrating their SQL servers from on-premises to Azure SQL DB. And the other one is the ARM template to deploy and automate the deployment to multiple SQL VMs and always on configuration as well. Now, I would like to hand over it to Sumit, who will be demoing the solution we provided to Udan to migrate this 3.5 terabyte database with a cutover of around 1 hour. Sumit.
Sure, thanks, Naveen. Hi, everyone. So to demo this particular utility or the tool that we have designed, I have created a video to showcase these things to you. So I'll be playing the video and I'll keep on pausing to explain each and every step throughout the demo of this tool. So one of the design goals of this particular tool is that we would like to do a VLDB migration to fill in the first party tool gaps. As Des and Naveen already informed, we don't have any tool wherein, for example, we can do a database migration from Azure SQL DB to Azure SQL MI, or maybe from Azure SQL Hyperscale to Azure SQL MI, right? So we don't have that tool available. So one of the design goals of building this tool is to fill in that particular gap. The system that we have designed must be performant to do data loading at faster speeds. So for example, if I have to migrate a database of say 10 terabyte in size, I do not want to wait for 5 or 6 days to complete the data migration. Rather, I would like to do this migration in maybe within 24 hours. Uh, we do not want to reinvent the wheel, whereby writing a connector, writing some line of code, to do the data migration. Rather than that, we are using existing SQL bulk copy APIs, which are already there in public. And we are using a connector built by Microsoft Team to read the data from SQL as a source and write the data to SQL target, through something called as Apache Spark SQL connector. Uh, Now, when we are talking about VLDB migration, we also must understand that the scale at which the data must be migrated should be huge. When the data is less in size, we should scale down, and when the data is huge in size, the system should scale up. And that is the exact reason why we have leveraged Spark as an engine, wherein it can help us to scale up and scale down, on demand. Uh, we wanted to build a single solution that provides initial data loading capabilities and incremental change capabilities. The reason for this is we wanted to make sure when we are representing this tool to the customer should be able to do offline as well as online migration. In offline migration, you already have a downtime. You can take maybe 10 to 12 hours of downtime to migrate, let's say, 5 terabyte of data. However, there are certain business challenges, business situations wherein you want to do data migration in an online mode. For example, in Uran's case, their downtime cutover timelines were very, very aggressive. They wanted to do this the entire migration plus including the cutover time in less than 1 hour. However, we created the solution to meet these aggressive timelines, wherein you can start data loading, let's say on Monday morning. Throughout the week, you can keep on migrating the data or the incremental changes from source to target. And let's say on Saturday night, when you have the cutover of 1 to 2 hours, you can bring the application down and move the data completely from source to target. So these were some of the design goals which encouraged us to build this particular tool. Um, Going forward, I'll explain you what setup do we have while we design this tool. So we are leveraging Azure Databricks Spark cluster to leverage Spark framework. And as I told you, Spark allows us to read the data in a faster processing times. It allows us to scale up and scale down the infrastructure on demand. As the data size increases, it automatically scales up, and as the data size decreases, it automatically scales down. Another reason of utilizing Spark is that it allows us to partition the data and hence do a parallel read of data and write to the target. We are utilizing Azure Key Vault service for storing credentials and secrets. In any of our scripts that we have written as part of this solution, we do not want customer to expose their credentials and service, username, passwords, even the server names, the database names. So everything will be stored in Azure Key Vault, and be it a T-SQL script or a Python notebook, which is part of the this entire solution. We read all these secrets directly from Azure Key Vault. We have bunch of Python notebooks for data migration, and these Python notebooks would do both the initial data load as well as the incremental changes. For incremental changes, we are making use of Azure SQL Change Data Capture, which is a time and tested tool and great feature since a very long time as part of SQL products. Uh, then we create a bunch of SQL objects on both source and target databases, and these include some of the stored procedures, some temporary tables, and the views. Uh, all these three objects will be part of both source and target. Uh, User do not have to worry about what to do with these procedure, what will happen once the data migration is done. We will do the cleanup of these objects immediately after the data migration is done. And at the end, we have created a data migration tool. So when we start building this tool, it was all script based, and we got very constructive feedback from our customers that, hey, this is all great, but I need a great UI. So we have come out with a UI, which is a .NET based application for better user experience. So next, I'll show you the eh, excuse me, let me just start the slideshow again. Yep. All right. Yep. So next I will show you the Azure Key Vault service, which we are using to store the credentials. And you would see that this Key Vault would have all the parameters and the variables that we are using as part of our T-SQL script and the Python notebooks. And as I said, we are not exposing anything in public or as part of any notebook whatsoever. Then we have Azure Databricks setup. In Azure Databricks setup, we are making use of the infrastructure with 8 worker nodes. These worker nodes would do the heavy lifting of reading the data from source and writing the data to target. As you can see, we are using kind of a commodity hardware wherein we'll start with 2 worker nodes and it will scale up to 8 worker nodes. And this scaling would happen automatically. As the data size increases, we will move from 2 to 3, 3 to 4, 4 to 5, and so on and so forth, up to 8 nodes. Each node would have 4 cores and 14 gigs of memory, which is a very minimal configuration that we are making use of. So in all, you would see that if we are running at a full throttle, we would be running at max workers as 8, which means 8 virtual machines will run in the background, and each virtual machine will have 4 cores, which means that a total of 32 worker threads would be able to read the data per table from source. Total of 32 worker threads would be able to write data on target. And I'm talking from the perspective of per table. So if we are reading multiple tables at one go, those many worker threads would be spawned by Spark ecosystem. Then these are the notebooks that we are making use of. These are 8 notebooks. One of the notebooks is a configuration notebook, which just set up the environment on Databricks, and the rest of the notebooks would do the initial and the CDC load. Next, I'm going to showcase the setup on SQL. So this is my source SQL environment, which is Azure SQL Database. And for the benefit of to save some time, I'm just going to showcase you one migration of one particular table, very small table, but it will give you a summary of how we are doing the stuff. So we are using a table called customers, and this customers table is having a total of 10 records. It is on Azure SQL database. So right now, uh, this is set up on Azure SQL, and then my target would be Azure SQL MI manage instance. And here you would see that we have a customers table again, but I will be dropping this table, creating a new schema of this table, and now this table is empty. There is no index, nothing. It's pure heap table. And this is what our tool is. We call this tool as a data migration tool, but the name could change. If you can see this tool, we have given for the simplicity, we have given a serial number to each and every step of this tool. So as you go from step number 1 on the right hand side to 2, 3, and then 4, 5, 6, 7 up to 10, you would see that you just have to follow each and every step one by one, and you will start moving your data. You don't have to do anything extra apart from using this tool. Whatever setup has been done already done on Databricks, it's all there. And after that, you don't have to touch Databricks, or you don't have to go back to Azure Key Vault, or you don't have to go back to SQL. Uh, we have tried to make use of this tool to give a single pane of glass to do each and every activity as part of this migration. So if I click on step number 1, it will create a bunch of startup scripts. It will create stored procedures, tables, some views on the source database. And similarly, if I click on second step, it would do exactly the same thing what it has done as part of step 1, but on the target environment. Then in this particular window, we will give name of the tables which we have to migrate. Now, let's say you have 100 tables and you just want to migrate uh, just 10 of them. We allow you to stagger the migration of the database based on number of tables. So if you want to migrate 10 tables on Monday, remaining 10 tables on Tuesday, 10 tables on Wednesday, we allow you to do that. But if you want to do migration of all the 100 tables at one go, that is also possible as part of this tool. So since in this demo, I'm migrating just one table, so I will punch in the details of this one table as part of this form. And I'll show you how to do, for all the tables in one go. So I will write the name of the table over here. And if you see, uh, a view is getting generated, a name of the view is getting generated automatically. And this nomenclature we have given, I mean, this kind of weird nomenclature is just to make sure that this nomenclature is very not very common across customers' environments, right? So we auto generate this view as part of the base table that we have given. And then there are bunch of columns which are being used by Spark. As I mentioned earlier, Spark makes use of partitioning. And because of this partitioning, it generates number of T-SQL statements on source and read the data and move the data to target, right? So if there is a skewness in the partition, skewness of data in partition, there could be a possibility that overall scheme of things will fall down, and you might not get the kind of performance you expected to. So it's important to run this tool by giving correct partition information. Now, how to identify that partition information? I'll tell you how to do that. But for this example, I'll just give some random number, 1000 over here, because I just have 10 records in the table. So it doesn't matter what partition information I give here. Number of partitions, 32, means I will be making use of 32 threads in order to read the data from source and migrate the data to target. Is CDC required means that do you need online migration of this particular table? Meaning that do you need incremental changes to be flown from source to target for a particular table? Yes or no? Uh, then you have to select which particular notebook do you want to run for this particular table, and you have to also specify what kind of index do you have for this table. So there could be three possibilities at a very high level. That a table could be having a clustered index, it could be having a clustered column store index, or a heap. So you have to select one of them. This is necessary because based on this, we actually partition the data for that particular table. So once you capture all these details, you click on insert button, and this information will be inserted into both the source database and the target database. These will be inserted into the custom tables that we have built as part of step 1 and step 2. So now there is an import button as well. Now this import button basically can read the data from a CSV file, and this CSV file would be generated will have to be generated manually. We have given a script as part of this solution. So if you have to run, if you have to generate data for the data extraction, data configuration form, for all the tables at one go, you just execute the script. This script would iterate through all the tables in the database and generate information like partition column, lower bound, upper bound, number of partitions, and stuff like that. So you do not have to remember, or you do not have to calculate these numbers for each and every table. This script would be a friend for you. So you can refer to this particular script in order to punch in information in the data extraction config form, this particular form. Right. So if you import, if you import the CSV file, it will automatically import data for all the tables. Then we'll come to step number 4. This particular step would execute. Okay, I'll explain you one particular important point here. There is a button called generate script. So if you click on this generate script, it would take its own sweet time in order to generate create table statement for all the tables present in that database. So if you have 2000 tables, it would iterate through all the tables and generate only the plain vanilla create table statement, uh, with the exception of getting information about compression for that particular table or partitioning. So if you have a table having compression or partitioning or both, the create table statement will have the syntaxes for compression and partitioning. And we want you to create the partition scheme before you create the table on the target database. So you can generate this particular script in order to generate the schema on the target database. We also have a button called Start Cluster and Execute Notebook. So basically, as I said, you don't have to go to Databricks in order to start Databricks cluster or stop Databricks cluster and things like that. If you click on this particular Start button, the Databricks cluster will automatically start running. And again, I mean, we don't want you to go back to multiple different services. Now we will execute step number 4. So step number 4 will basically take the information of the customer's table and punch in some of the metadata information in some more tables on source. So once we click that, the information is persisted on source, and similarly, the same information will be persisted on target, on certain tables on target. Now, at this point in time, we are ready to do a full data load, the phase 1 of this particular tool. So since the database cluster is already running, we would click on Execute Notebook button, and this will give you a view of all the notebooks which are present on Databricks, right? So as I mentioned earlier, we have a configuration notebook. This notebook basically sets up the environment for a particular set of tables which are part of this particular phase 1 of the migration. So as soon as you click on execute button on the data migration app, you would see that a job ID would be created. I'll just click on the execute button. Yep, I'll just click on execute button and you would see a job ID would be generated. This means that Databricks has accepted this request, and we just have to wait for maybe 30 to 40 seconds in order for configuration to complete. So this configuration notebook is basically reading some metadata information from the source database. Whatever information we have punched in onto the source database as part of step number 4 will be consumed by configuration notebook, and it will be persisted on Databricks cluster. And based on this configuration notebook and the data persisted on Databricks, uh, uh, our next set of notebooks like initial load notebook 1, 2, 3, and 4 would consume the information from configuration notebook and would start executing the script. So we just have to wait for a couple of minutes more. Must be, yeah. So it is done, success. So now we are ready to click on execute button against initial notebook 1, and job ID has been generated. It means that this step has been accepted by Databricks. And right now in the background, the data would be migrated for the customers table from source to target database. So again, it would take hardly 30 to 40 seconds to complete this step. So we just have to wait. So for a smaller table, you might see that we are just making use of a couple of worker nodes. But as the size of the table increases, or if the number of table increases, it means that we will scale. The Spark cluster automatically scales from 2 to 3 or 4 or 5 or 6, right? Now, one important thing to note over here is that you can run a notebook 1, 2, 3, and 4 in parallel after the configuration notebook is complete. So we just have to wait for configuration notebook to complete before running any initial load notebook. Now coming back to SQL, you would see that on target database, now the data would be populated. You will get all the 10 records over here, what were present on the source database. Right. So next is next is to start the second phase of this process. Now, to start the second phase, basically it means that we need to get the incremental changes from source to target. Now, in order to do the incremental changes, it is important for us to identify and make sure that the target table would have a primary key and or a unique key present, because in absence of primary key and unique key, we do not consider those tables for incremental loads, right? The incremental load would fail. So it is important that if you want a table to have the incremental changes, or if you want to do an online migration of that particular table, you should have a primary key or a unique key present, right? This is a necessary requirement for the incremental load. And that is why we have given step number 8 to verify those constraints. So uh, in order to create these primary key and unique key constraint, I'll go back to my target database and execute this script. This script would basically create a bunch of unique constraints and primary key. So even if one of these constraints are present, either the primary or unique key or both, anything will work. This is done. We'll come back to the app. Okay. So right now, once the in order to showcase how the incremental changes happen. So here I'm just inserting a record row number 11 to my source database and updating one of the records which is on row number 10. So there would be two changes that I have done on the source database. And while these changes are happening, you would see that these changes would be persisted into the change stacking tables of Azure CDC. Remember, Azure CDC is running is enabled on this particular table. So these changes would have been persisted in the CT tables or change stacking tables on the source. So once this is done and we are ready, we want to still confirm whether there are constraints present on the target table, which is very important. Otherwise, the incremental load won't work. So we have given step number 8 to execute that. So once you execute, and if the script executes successfully, it means that there are constraints over there and we are ready to move ahead with incremental changes. Now, before that, we just have to execute one more script to set up the uh, configuration on target so that the target would start accepting those incremental changes. So we are done with that step as well. And now we are ready to go back to notebooks and execute remaining notebooks, CDC load notebook 1, 2, and 3. So basically, CDC load notebook 1 would read the changes that are persisted in the CT tables on source into some temporary structures on source database. Then CDC load notebook 2 would basically migrate those changes from the temporary structures on source to target. And similarly, the third notebook would basically do the merge. Now, this particular view of whatever view you were seeing, as of now, the CDC status, it would just tell you that the steps have been completed or are they in progress, right? So if you see completed under load at source, it means the CDC load notebook 1 has been completed. We have been able to successfully read the data from CT tables into our permanent tables, and so on and so forth. So we have given this view so that you can have a look at each and every table's progress. So once you do not see any record for a particular table, it means that all the 3 steps have been completed. So the merge or the incremental changes have already been applied to the targets. So if you do not see any record over here. So since all the 3 steps are done, we'll come back to the target again and see whether the changes are there. And yes, the changes are persisted on target. So row number 10 has been updated and row number 11 has been added by this solution. So the next step is basically very important and very critical that, hey, you have created a bunch of, so basically, yeah, important point to be noted over here that it's not possible to run CDC notebooks 1, 2, and 3 manually every time, because as I said, you might start the migration on Monday and you end up doing a cutover on Saturday. So during this time period, you can schedule these notebooks on Databricks. So you can go to Databricks, click on schedule button, and you can say that, I want to run these notebooks, every 5 minutes. Mind you, these 3 notebooks run in async mode. So no matter whatever is the sequence of these notebooks, even if they run one after the other, or the second notebook is executed before notebook 1, nothing wrong is going to happen. The data will eventually go during the next iteration of the execution of the notebook. So it is critical for us to understand that these notebooks can be scheduled, and you can anytime pause or delete the schedule. So one of the critical aspect is that, hey, you have created a bunch of objects on my source and target environments. How about cleaning it up? So we have given a couple of buttons over here to clean up the source and target environments. So you click on the source and source cleanup tab. It will go ahead and remove all the objects, whatever we have created from source, and similarly, it would do the same thing on target, right? So this concludes my demo on the homogeneous data migration utility using Spark. Naveen, over to you.
So I'll take over here. The key takeaways and resources that we want to give you. So maybe if we just go to the next slide, and thank you for that excellent demo, Sumit. The key takeaways from our session today, what we want to make sure that you're all going away with are understanding the drivers and the discussion points that are central towards any modernization or migration discussion. We talked about those right at the beginning and tried to give you some points in terms of either IPs that we've created or discussion points that you can use to mitigate some of those areas that are seen as blockers or common kind of discussion points around those migration scenarios. Migration tooling, we covered the various options we have in terms of the tooling for migrations. And while we know that there are quite a lot of migration tools out there, we hope that one of the key takeaways of this session was to try and explain that we are giving you the options for these various tools but we do understand that you need some guidance in when to use what tool. We hope that we've given you some guidance there. Migration patterns and approaches, we've gone over various patterns and approaches for those migrations. You've heard from Naveen earlier on Udan and their journey in terms of their requirements, as well as seen the very valuable Spark demo for using Spark to migrate at scale. And finally, we want to just leave with a point on, testing. Testing is key. Post-migration optimization as well is key to a successful modernization journey from SQL to Azure SQL. So don't, skimp on pre-migration testing and post-migration optimization. Very, very important parts of an overall successful migration to Azure. And next slide, please. And finally, just wanted to list very quickly some of our success stories, some of our recent success stories, direct you to the technical blogs and our documentation, where you'll find all of the IPs and within the deck as well. You'll have the direct links to those IPs, but we have many, many more IPs also. This was just a small subsection of some of the more recent IPs that we've created. And if there are any questions at all across anything that we've presented today, or indeed in general, please feel free to reach out to us. Our email address is linked in the contact section here, and we'd be more than happy to hear from you. So with that, thank you so much for taking the time and listening to our session today, and we'll open it up to Q&A now. Thank you.